In this video, we're going to go through critique number 2 in how to do it and just basically giving you an example of how you can look at an article. So this is the impact of nurse staffing and levels and nurses' education on patient mortality in medical and surgical wards, an observational multi-center study. So a couple things about this study, about this first. So when it comes to the research objective, you can see right here, the objective of this study was to explore the relationship between nurse staffing levels and patient mortality on medical and surgical wards, considering nurses' education level, team composition, patient's age, and comorbidity. All right, so overall, that is not a bad research statement. It includes the study factor. It also includes the response variable, and it also includes some extraneous variables. But what it doesn't really do is it doesn't really specify the population of interest, but it's inferred. So the relationship between nurse staffing levels, that's going to be our study factor, and patient mortality. Did the patient die? Yes or no? Well, that's going to be the response variable on medical surgical wards. So what that really means is in patients, in med-surg patients. So if you're going to say this the best way, it would be what is the relationship between nursing staffing levels and patient death in med-surg patients? And that's pretty much it. Now, when we get to the study factors, we'll talk a little bit more, but what I want to mention is that factors are anything that can potentially affect the response variable. Now, if it's something that we are interested in studying, then it's the study factor. And if it's something that we don't care about, then it's an extraneous factor. So in this particular example, the nurse staffing level is the study factor. It's the factor that could affect mortality that we care about. And then they say considering, and they say this list of things, these are other things that are factors. These are things that could affect mortality, but we don't really care about them. That makes them extraneous factors. So we don't really care about the nurse's education level, we don't care about the team composition, and we don't care about the patient's age, and we don't care about the patient's comorbidities. However, we do know that those things may impact patient death. So if we don't consider them, then we can or don't control for them, we might end up with them being confounding factors. All right. So as far as the statement of this goes, right here we see this was an observational longitudinal study retrospectively analyzing the control group of a stepped wedge randomized controlled trial, which is the SWRCT. Now, it is extremely important to really parse what's going on here. So observational studies are prospective studies, but this is telling us that it's retrospective, but it's also mentioning the word clinical trial. So what happened here is that there was a clinical trial that was carried out a couple years back, and then a group of researchers said, hey, we've got this whole bunch of data sitting there not doing anything. Maybe we could publish another study out of that. So they said, okay, let's look back and see what we can find out. So the data already exists. It's already been collected. The study question was not decided in advance. How it was going to be measured was not decided in advance. That makes this a retrospective study, which the study says. But it's not observational because observational studies are always prospective. This is basically looking at chart reviews or data reviews of data that's already collected. That makes it a historical or retrospective cohort study. All right. So there we've got that. Then we have the population of interest, and the population of interest in this case, says all patients admitted to the study wards during the control period from blah, 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 blah were included in this study. So if there was any patient who was admitted to the unit that was being studied, then they were included in the study during those timeframes. That's a little bit, they're kind of mixing their sampling process and their inclusion-exclusion criteria right there. So they're also saying that pregnant patients and children below the age of 17 were excluded because in the original randomized controlled trial, the intervention was not suitable to those patients. Now, that is a reason for excluding it, but the question is it a good reason? So let me ask you this question. When you hear the term med-surg patient, do you actually think, well, that includes kids who are 16. Or do you think med-surg patients are adults, so 18 to 21 and up? And if the answer is the latter one, then there's no problem in excluding 17. If in your head, when you hear the term med-surg patients, you're going, that includes 15-year-olds, then you could say, well, there might be a problem there because you're not going to be able to generalize it to general med-surg patients. Now, the other thing you have to ask yourself is, when you hear the term pregnant patients, do you think med-surg patients? Now, it is possible that you can have a med-surg patient who is pregnant. Let's say that you have someone who is, say, 10 weeks pregnant and she gets pneumonia. Would she be considered a med-surg patient? And the answer is probably yes. But on the other hand, how many young, relatively healthy pregnant patients are on general med-surg floors? Generally speaking, I don't think that people are thinking, oh yeah, we need to include all the pregnant patients when we're talking about med-surg patients in general. So, but you have to make that determination for yourself. So when you're critiquing the sampling method and the inclusion-exclusion criteria, these are the things you need to think about. Is it appropriate to exclude patients who are women and patients who are kids in this case, or below the age of 17? Does it make sense that you would do your study in one place? Well, that's not really part of inclusion-exclusion so much as it is sampling method, and that makes this a strongly convenient sample. So now we're going to move on and we're going to talk about the response variable. So again, remember that the term outcome is sometimes used in research literature to mean the response or dependent variables. So outcomes right here. So we had primary and secondary outcomes. A primary outcome means the main thing we're interested in, and secondary outcomes are things we're not as interested in, but we're curious about. So just looking at the top, the primary outcomes were crude mortality, unexpected death, death after 72 hours after CPR, and death until 72 hours after unplanned ICU. Now, what that means is, first of all, let's remember, when we looked at that objective statement, it said mortality, and mortality is not actually a response variable. The response variable is what you measure in an experimental unit. If the experimental unit is a patient, well, what do you measure in a patient? Mortality, or is the patient dead or not? What you measure is, are they dead or not? And so that makes mortality a statistic. It is a statistic that you're going to calculate after you do the study. So what you're going to measure as part of the study is the patient dead or not? Now, what is crude mortality in this case? That means, is the patient dead? Yes, no. That's it. That's the only thing we care about is yes or no. But we also are going to record some additional aspects about death. Was their death expected or unexpected? So that's also going to be a yes, no. And then we're going to say, was their death after CPR within 72 hours of CPR? So the idea being that, well, the patient died, coded, we brought him back to life, and then they died again within the next 72 hours. And if the patient did, then the answer is yes. And if the answer is no, they didn't die within that 72-hour window, then no, they're still alive for the purposes of this study. And then they did the same thing for patients who were admitted to the ICU unexpectedly. So if the patient came, because remember, this is being studied on a med-surg floor. So if the patient comes into the ER and they go, yeah, this patient's in pretty bad condition, let's send her to the ICU, we're not counting that patient. If the person was admitted to a med-surg unit and then unexpectedly had to go to the ICU, then we're going to include that. Then they do some additional explaining here, and they say that when we say unexpected death, what we mean is a person who died without a DNR, without palliative or terminal care, or without a family member attending during that process, or without ceasing or limiting active therapy in an untreatable disease. So basically, if the patient had any one of those things, then we considered it to be an unexpected death. Now, you have to ask yourself, does that make sense? And if the answer is yes, then maybe that's okay. And it would have been really nice if you look up in the lit review area of this study, did they talk about what an unexpected death means? Because if someone else has already done a study on unexpected death and they defined it a certain way, and then this study is defining it a different way, well, why did they choose to define it differently? So that's something that you need to think about. And then they also say, additionally, a composite outcome, which is the combined mortality rate, is unexpected death, death after 72 hours or within 72 hours of CPR, and death within 72 hours of unplanned ICU. So all three of those things together is called the combined mortality rate. And then they actually say why they did that. And the reason why they did that is they thought it was an estimate for adverse mortality, which they thought could be sensitive to missed care. So the idea is if there's not enough nurses to take care of you, well, maybe you're not going to be noticed when you start going south, and there's going to be failure to rescue. There's going to be failure to take adequate intervention. And maybe that's why you get transferred to the ICU and then die, or have CPR and then die. And then there's secondary outcomes in the study, which are additional response variables, which is, did the patient have CPR? Yes or no? Was there an unplanned ICU admission? Yes or no? And then the hospital length of stay, how long the patient was in the hospital. So every single one of those response variables up until length of stay is nominal. And then the last one is numerical or continuous. So that would be your response variable. Now, in the next section, you're going to have to critique the response variable and its planning, or and their choosing of it. Why did they do it that way? So everything that we just talked about, as far as, are these good decisions that they're making? Are they saying, they didn't say why they made this decision except for one, but they didn't cite any other studies that did it that way. So then what you have to do is you have to go back to the lit review and see, did they support any of the decisions that they made up in the lit review? Now, when it comes to the factors, we have a couple of factors that they chose here. So you see patient characteristics. So remember that earlier in the study, they had identified some potential extraneous factors as the patient's age and their comorbidity. The older a person is, the more likely they are to die. And the more diseases a person has, the more likely they are to die as well. So they thought that those things would be important potential factors that could affect mortality, and so therefore they have to control for them. And then you see the staffing and education, and again, the thing that they most wanted to know was the staffing level, but they also wanted to know the nurse's degree of education, because they thought that that might also play a part. Now, this is done in a European country, so you can't necessarily assume that they use the same terminology that we do here in the United States when it comes to describing education levels. So you should read this part here and make sure that you understand it before you go and critique the factor level in your study. All right, so now we're going to move on and we're going to talk about the statistical analysis. So in the statistical analysis, what we can see over here on this right side is they talk about a few items that they did, and in the end, the important thing is they used a linear mixed model. So anytime you're dealing with the term model, what that means is you're doing a regression analysis. So you're going to look in the course under regression analysis, and you're going to read that little bit, and it's going to give you an idea of what you're looking at. And what they did is they were looking at using the linear mixed model to find estimates of mortality. So let's go ahead and scroll down now. That here you can see all of their results here, but we're going to scroll down to the tables. So here you see a list of the tables of how many hospitals, blah, blah, blah. And then you see comparison of study measures between the hospitals. So they're basically trying to say that the hospital itself was not an extraneous factor, is what they're trying to show here in this. And then finally we get to the important one, which is table number 3. So in table number 3, they have two models. Remember, they did this twice. So in the first model, let's look over here, right here. What they said is the point estimate of crude mortality was -3. And then the 95% confidence interval was from -10 to +4. Now, because that confidence interval crosses 0, it includes 0 in the mortality. That means that it's possible that no one died as a result of the study factor. Then you all can also verify that by looking at the p-value right here. So the p-value. The p-value is 0.4, and in order to be significant, it would have to be less than 0.4. So no matter whether you're looking at the inference statistic from either a standpoint of confidence intervals, or whether you're looking at it through hypothesis testing, mortality was not significant. And actually, if you look at all of these, none of them were significant using Model 1. Now, it would be a really good idea to go back up and listen or look at Model 1. So here, Model 1 adjusted for clustering, random effect, and study time, fixed effect. Model 2 adjusted for random effect, study time, and the proportion of nurse bachelor hours, nurse assistant, logistics support staff, and comorbidity index and age. So what they did was, when you control for all of those things, what do we find out? And so if you look over here, what you'll see is that unexpected death is significant. Death after CPR is not quite significant. Sorry, that is significant, but not as significant. Death after CPR, whether they had CPR is significant. Whether they died after CPR is significant. And unplanned ICU admission is not. And then the rest of these were not. And then combined mortality rate was. And the hospital length of stay was not. So it looks like unexpected death, getting CPR, and dying after CPR, and combined mortality, all of those were significant once you control for those other factors. So when you do the critique of your statistics, what you're going to be doing is talking about how they reported them, and then you're also going to include the pertinent things. So in this case, because they reported a whole bunch of different things, but only a few of them were significant, what you would do then is you would say, basically describe all that, and then you would say that the ones that were significant were unexpected death, CPR, death after CPR, and combined mortality rate. And then you would go ahead and include those factors. Those numbers in your study. One of the mistakes that a lot of students make is they don't include the actual numbers. Now, in this case, it's pretty complicated. In some cases, the article is very, very simple. Like if you're just looking at an infection rate and it's like, well, the infection rate was this. The infection rate was this before the intervention, and then it was this after the intervention. And the net reduction was X amount. Well, then you need to say what that was. And if they say the p-value is 0.043, then you need to say, and with the p-value of 0.43. So make sure that you're including the pertinent statistics and actually report them, not just describe them when you do your critique. We're going to ignore this, and that's pretty much it. So hopefully that should give you an idea of what to look for when you're doing a critique for Critique 2.